the 3rd of September, 1940. A small workshop tucked inside the grounds of the Royal Small Arms Factory in Enfield Lock, just north of London, and 2 men are hunched over a workbench littered with scraps of metal. Outside, the skies over southern England are thick with the drone of aircraft engines, and the newspapers carry daily counts of losses from a battle that has not yet been won. Inside, Major Reginald Shepherd and Harold Turpin are not working with precision-milled steel or carefully forged components. They are working with stamped sheet metal, the kind used in biscuit tins and motor car bodies. A length of tubing that might once have been a length of scaffolding pole lies beside a spring salvaged from a furniture workshop. This is not how weapons are supposed to be made. This is how Britain, in its darkest hour, decided weapons would have to be made anyway. The gun taking shape under their hands will become one of the most maligned, most mass-produced, and most quietly effective weapons of the Second World War. It will be sneered at by soldiers who handle it for the first time, nicknamed the plumber's nightmare and worse, and yet it will arm resistance fighters from the forests of Yugoslavia to the canals of Holland. It will be smuggled in pieces, assembled in barns, and used to kill occupying soldiers in alleyways across Europe. This is the story of how Britain, stripped of the industrial luxury to make anything beautiful, made something that worked instead, and in doing so, turned the language of scarcity into a weapon all its own. By the summer of 1940, Britain stood essentially alone and almost unarmed. The catastrophe at Dunkirk in late May and early June had seen the British Expeditionary Force escape across the Channel with their lives, but precious little else. Records compiled after the evacuation showed that the Army had abandoned roughly 2,400 guns, 60,000 vehicles, and almost all of its automatic weapons on the beaches and in the fields of northern France. The Sten's predecessor in British service, the Thompson submachine gun, had to be purchased from the United States at considerable expense in dollars Britain did not have, since America had not yet entered the war and demanded hard currency for its arms exports. Each Thompson cost in the region of $200 to produce, an extraordinary sum for a nation now facing invasion with a home guard armed in places with broom handles and shotguns. The maths were brutal and unforgiving. Britain needed hundreds of thousands of automatic weapons, and it needed them within months, not years. Traditional submachine gun manufacture relied on machining processes that demanded skilled labor, precision lathes, and components measured to fine tolerances. Each Thompson required somewhere in the order of 30 hours of machining time. Britain's factories, many of them now repurposed and overstretched, simply could not produce weapons at that rate using those methods. There were not enough skilled machinists. There was not enough machine tool capacity. There was, bluntly, not enough time. The existing solutions had all failed in one way or another. The Lanchester submachine gun, a close copy of the German MP-28, had gone into limited production for the Royal Navy, but it too required extensive machining and was never intended for mass infantry issue. Importing weapons from America offered no long-term solution, since Britain's gold and dollar reserves were finite and shrinking with every convoy that crossed the Atlantic. Meanwhile, German forces stood 20 miles across the Channel, and an invasion fleet was being assembled in French and Belgian ports. The problem was not simply technical, it was existential. Britain needed a weapon that could be built by unskilled labor in small workshops using materials that did not compete with the steel and machine hours already earmarked for aircraft, tanks, and ships. It needed, in effect, a gun that almost anyone could make and almost anyone could use, and it needed it yesterday. The answer came from inside the Enfield factory itself, and it bore the initials of its creators stitched into its very name. Sten stood for Shepherd, Turpin, and Enfield, a deliberately plain acronym for a deliberately plain weapon. Reginald Shepherd was a serving Army officer with design experience, while Harold Turpin was a design draftsman who had previously worked on the Lanchester. Together, working under conditions of considerable urgency, they stripped the submachine gun down to its barest functional essentials. The genius of the Sten lay not in any single innovation, but in a ruthless philosophy of simplification. The receiver, the tube-like body that housed the working parts, was made from a length of steel tubing rather than a machined block, cut to length and welded rather than carved from solid metal. The stock was, in early versions, little more than a metal rod bent into a T-shape, sometimes derided by soldiers as resembling a bicycle frame rather than a proper rifle stock. The trigger mechanism used the simplest possible blowback action, where the force of each fired cartridge threw the bolt backwards to eject the spent case and chamber a new round, with no need for the complex gas systems or rotating bolts found in more sophisticated weapons. Many components were stamped from sheet steel using presses rather than machined, a process closer to manufacturing a biscuit tin than a rifle. The numbers tell their own story of austerity transformed into virtue. Where a Thompson submachine gun demanded around 30 hours of machining and dozens of distinct manufacturing operations, a Sten could be produced in roughly 5 hours of labor using a fraction of the machine tool time. Costs fell correspondingly, from the Thompson's roughly $200 per unit to a Sten that cost the British government somewhere in the region of £2 and 10 shillings to produce, a startling difference even allowing for currency conversion. The weapon weighed approximately 3.2 kilograms unloaded, modest enough for a teenage resistance fighter or an elderly Home Guard volunteer to carry without strain. It fired the standard 9mm parabellum cartridge, the same ammunition used by German forces which would later prove a quiet advantage to resistance fighters who could resupply themselves from captured enemy stocks. Production was dispersed deliberately across hundreds of small workshops, garages, and light engineering firms throughout Britain, rather than concentrated in a handful of vulnerable large factories. This was not merely an economy measure but a strategic one, since it meant that the bombing of any single facility could never halt production entirely. Components arrived at central assembly points from workshops that might, in peacetime, have made bicycle parts or domestic hardware. By the time production wound down, estimates suggest that somewhere between 3 and 4 million Stens had been manufactured across all variants, though exact figures remain difficult to pin down given the dispersed nature of wartime production and the destruction of some records. It became, by sheer volume, one of the most numerous firearms ever produced. In the field, the Sten earned both contempt and grudging respect, often from the very same soldiers. British regulars frequently complained about its tendency to fire unexpectedly if dropped or knocked, a consequence of its simple, sometimes crude, safety mechanisms in early models. Yet, for the resistance movements of occupied Europe, its very simplicity became its greatest virtue. The weapon could be broken down into pieces small enough to conceal beneath floorboards, inside hollowed-out furniture, or strapped beneath a parachute container destined for a moonlit field in rural France. The Special Operations Executive parachuted thousands of Stens into occupied territory throughout 1942 and beyond, arming partisan groups in France, Norway, Poland, and what was then Yugoslavia. Maquis fighters in the French countryside used Stens in ambushes against German convoys, valuing a weapon that could be hidden in a hayloft one day and used in an attack the next. In Warsaw, resistance fighters during the uprising of 1944 relied on smuggled and locally improvised Stens, some manufactured in secret workshops modeled directly on the British design, since its simplicity made it almost as easy to copy as to obtain. If you are finding this interesting, a quick subscribe helps more than you know, and it costs nothing but a moment of your time. The psychological impact on occupying forces, though harder to document with precision, appears in scattered accounts of German soldiers' wariness in areas known to be supplied by airdrops, aware that almost any farmhouse might now conceal a weapon capable of killing at close range. Records of specific operations remain incomplete, since resistance activity by its nature left little official paperwork on the Allied side, and German records of partisan actions were often destroyed or lost amid the chaos of retreat. What survives are fragments, after-action reports, memoirs written decades later, and the weapons themselves recovered from forests and farmhouses across the continent. The comparison with German efforts at similar weaponry reveals just how unusual Britain's approach truly was. Germany's equivalent submachine guns, the MP-38 and later the MP-40, were sophisticated and well-engineered, using folding metal stocks and quality machining that made them reliable and accurate, but also expensive and slow to produce by comparison. Each MP-40 cost considerably more in materials and labor than a Sten, and Germany never achieved production numbers that approached the British weapon's eventual totals relative to need. The Americans, for their part, eventually developed their own answer to the problem of cheap mass production in the M3 grease gun, a stamped metal submachine gun strikingly similar in philosophy to the Sten, though it arrived later in the war, entering service only in 1943. The intellectual lineage was clear enough that some historians have noted the M3's design owed a conceptual debt to the British weapon that preceded it by several years. The Soviet Union pursued a different but parallel logic with its PPSH-41, also designed for ease of mass production using stamped steel, suggesting that necessity was pushing multiple nations toward similar conclusions independently. What distinguished the Sten was not that it was the best submachine gun of the war in terms of accuracy or finish, since by most accounts it was not, but that it was conceived earliest in the direst circumstances and proved that desperation could be engineered into a virtue. The historical impact of the Sten gun is difficult to measure in purely material terms, since its true significance lay as much in what it enabled as in what it directly destroyed. It allowed Britain to arm its home guard and eventually its regular forces at a moment when the alternative might have been fighting with whatever older weapons remained in storage. It allowed resistance movements across occupied Europe to receive a weapon that was, crucially, easy to maintain in the field without specialist tools or training, a quality that mattered enormously to fighters operating without access to armorers or spare parts depots. Later variants, particularly the Sten Mark V produced for airborne forces ahead of the Normandy landings, incorporated improved finishing and a wooden stock, suggesting that as Britain's industrial position improved, some of the weapon's roughest edges were smoothed away even as its core philosophy remained intact. The Sten's influence extended well beyond 1945. Its principles of stamped construction and minimal machining influenced post-war weapon designs across multiple nations, feeding into a broader 20th century shift toward weapons designed for mass production rather than craftsmanship alone. Surviving examples can today be found in collections including the Imperial War Museum in London and the Royal Armouries in Leeds, where visitors can examine firsthand the crude welds and stamped panels that once represented the absolute limit of what desperate ingenuity could achieve. Return, then, to that workshop in Enfield Lock, September 1940, with the Battle of Britain still raging overhead and invasion barges reportedly massing across the channel. Two men, working with tubing and sheet metal and springs scavenged from civilian industry, were not trying to build the finest submachine gun ever conceived. They were trying to build enough guns, quickly enough, cheaply enough to give Britain and its allies a fighting chance. They succeeded in ways that mere elegance of engineering could never have matched. The Sten was crude. The Sten was, by the unanimous testimony of nearly everyone who carried one, occasionally dangerous to its own user. The Sten looked, as more than one soldier observed at the time, like something assembled from spare parts in a garden shed rather than designed in a proper arsenal. And in every one of those criticisms lies the secret of its success. It was built from rubbish, in the truest sense, from the offcuts and stampings and tubing that a desperate nation could spare without weakening its aircraft factories or its shipyards. It was built to be thrown away after use if necessary, replaced by another from the next batch rolling off the next makeshift production line. It was never meant to last centuries in a museum case, though many examples have. It was meant to last long enough to put a German soldier on the ground and let a French farmer or a Polish student walk away into the night. 3 to 4 million times over, in workshops and garages from Lancashire to London, ordinary materials became extraordinary instruments of resistance. The weapon that sneering regulars dismissed as a plumber's nightmare became, in the hands of partisans across an occupied continent, something closer to a lifeline. Britain did not win the war with the Sten gun alone, and no honest account would claim otherwise. But Britain could not have armed the resistance of occupied Europe, could not have equipped its own defenders,